Good morning, dear students. Right, today we continue the lesson from the place last week is stopped. Right, okay. So then last week, I think we discussed the quadratic function lesson. In that lesson, we discussed how to draw a quadratic graph and what are the properties of a quadratic graph and the different types of existing roots for a quadratic graph. Yeah, those things I think you have again studied by watching the recording. Now I think that you are okay with that lesson, right? People, then today we'll continue the lesson from there. Yeah. Today we have to start. Okay. I'm going to start the today lesson, people, from the place this, right? Write down the subheading today as this way, people. The subheading is this. Write down the roots comma vertex of the quadratic function y equals ax squared plus bx plus c. This is the first heading today. The roots comma vertex of the quadratic function y equals ax squared plus bx plus c. People, you can remember last week I of course explained a particular method of finding the coordinates of the vertex and the roots for a given quadratic function. Now, for example, if I take this one, x squared minus 6x plus 8, people, can you remember this? We use the completing the square method here to determine that vertex and the roots. What method they are, people? There we have to complete the square on the right hand side. We said before completing the square on the right hand side, the x squared coefficient should be plus 1. At the moment, it's all right, no? X squared coefficient is plus 1. Okay. Now, people, I told you a method. We have to put here bracket perfect squared and this last term, same way we write. Within bracket, I told you of the x squared, without the square, only x we have to write, and minus x coefficient we have to divide by 2. 6 divided by 2 is, people, 3. That we have to write within bracket. And finally, we said we have to subtract. What, people? Always we subtract the perfect squared of this second number within bracket. 3 squared, 9. We have to subtract 9. And now we say we simplify here. 8 minus 9 is minus 1. And here x minus 3 perfect squared. Now we said how to determine the vertex. Change the sign this to what? Opposite. So therefore the coordinates of the vertex, people, we said 3, right? Y coordinate going to be minus 1, this one, right? And to find the roots, people, we said we have to equate this y to 0 and we have to find the corresponding values of x. Then we get that 2 roots. Okay, for roots, people, we have to set this y to 0. Once you put y 0, people, this will be 0. Then 0 equals this right hand side. 0 equals this right hand side mean, people, right hand side equals 0. From there we can start. Okay, so then I can write, people, here x minus 3 perfect squared minus 1 should be equal to 0, right? So once I bring this minus 1 to right hand side, we get plus 1. Then we get x minus 3 perfect squared. Okay, now I can subject x minus 3. The square we can eliminate, taking on the right hand side square root. You know, once we put the square root, we have to put plus or minus to right hand side. Then right hand side we have plus or minus square root 1. Now, people, you can bring this minus 3 to right hand side, we get plus 3, plus or minus. You know, the square root of 1 means nothing but people 1. Now selecting this plus sign, you get first root 3 plus 1. It's nothing but 4. One root is x equals 4. Taking minus sign, people, the other root we can obtain. What is that, people? 3 minus 1, it is x equals 2. This is how we find, people, the vertex and roots of this quadratic function. We did last week. In order to remind that only, I did this here, right? Now you can very clearly understand the same thing we are going to implement for this. Understand? So therefore, people, we are going to complete the square on the right hand side. We know before completing the square on the right hand side, definitely the x squared coefficient should be plus 1, no? Plus 1. So therefore, we have to start from there. What? We have to first convert this x squared coefficient to people plus 1. Let's see how to do this. Okay, right now. So then, people, we start from there today. No need to write this example because this kind of examples we have done last week. I did this one in order to remind your last week memory, in order to give a nice approach toward the very first part today. Okay, right. Then, people, this is what I do. I'm going to start from this quadratic function given y equals ax squared plus bx plus c. It's right hand side, people. I'm going to complete the square. You know, before completing the square, this x squared coefficient should be what, people? Plus 1, right? So then what I do is this, people, at the very beginning, I write this function y equals ax squared plus bx plus c. We should have, people, here x squared coefficient to be plus 1. What we do, people? That present x squared coefficient simply we take out from a bracket. Okay, yeah. Once you take a particular value as common factor out from an expression, people, remember that by that common factor, all the terms in the expression we must divide. Remember, once we take a particular value as common factor out from an expression, within bracket we must write something, no? That expression, people, we can very easily obtain by dividing the original expression by the value we took out as common factor. So therefore, I suppose to take this a out. Then, people, once I take a out from these 3 terms in the expression, what is the new expression we must write? Divide this all 3 terms in the expression by that simple way, which we have already taken out. Okay, people, right? So then what do you get here? Ax squared divided by a plus bx by a plus c by a. You can cancel down this and this. Then we get a, right? X squared plus b upon a times x plus c upon a. All right. We came to the first step, people. Now you can very clearly see within bracket this part has x squared coefficient plus 1. X squared coefficient plus 1. And now this is the one we now complete the square, right, people? Now come to the first stage, this. Right. Okay, people, the next one, what? Right, suppose we came up to this, right? Today, people will do with me. We together do. Right, now come up to this, right? Okay. Now, people, this is the one I'm going to use to complete the square, right? Tell me then what are the steps in completing the square? That also you can remember, right? We put this square bracket there. We open another bracket here. We put perfect squared. Soon after the perfect square, this constant figure we must write c by a and we have to subtract something. No, I leave the space to write them here. Right, okay. Now people, what we write within bracket, from this x squared without the square, only x we write, and plus. People, what is this? This one is, here we write what? Dividing this x coefficient, it is b upon a, no? B upon a, people, we have to divide by 2. That answer only we must write where? Here. You know, when we divide b, we divide by a, right? So this is the coefficient of x, no? B by a. That should be divided by 2. People, what is this really? B divided by a. This 2 means 2 by 1, no? Then this division sign you can write as a multiplication and take the reciprocal of this. We get something like this. B into 1 is b, a into 2, 2a. People, then when we divide b by a by 2, people, we get b upon 2a. So therefore, the one we must write here is b upon 2a. And people, we said always we subtract what? The perfect square root of this. When we square this, people, you have to square b as well as this 2a. You know, when you square b, what do you get? B squared. Then b squared divided by. When you square this 2a, people, 2a perfect squared means 2 squared then a squared. You know, 2 squared is 4a squared. This is what we get. This is what we get, people. Okay, up to here we came now, right? Come this 2. Okay, now the next part. Now people, I am going to simplify here. For this a and this 4a squared, common denominator, people, I can take 4a squared and this a. Common denominator we take as 4a squared, right? 4a squared. We take common denominator as 4a squared. Then what we get is this. Y equals a. Within bracket, what do you get? X plus b upon 2a perfect squared plus, I'm going to take here common denominator as 4a squared. Common denominator as 4a squared. People, once I take common denominator as 4a squared, this b squared won't change. That will be remaining as the same as minus b squared, Nadia, right? People, then tell me, by what value this c we have to multiply? Yeah, people, here we have a, no, but for this denominator a only, now we have written down 4a squared. Then tell me, people, in order to bring this a, the denominator, to what 4a squared, by what value this a we have to multiply? This value should be, people, 4a. Then only here 4a into a, this 4a squared coming. And now determine like that. In order to bring this denominator to the common denominator, this denominator we have to multiply by 4a. Then people, its numerator also we have to multiply by that 4a. Then this c will be 4ac, right? 4ac. 4ac. Right. So then, people, this is what we have. Right. Come out there. Right. Now, people, we'll do another little simplification there. What is that? From this term, right? From this term, I am going to take, people, from this numerator, I am going to take minus sign out. I am going to take minus sign out. You know, people, when we bring minus sign out from an expression, within bracket now we have to write change in the signs of the terms. whenever we take minus sign out. Okay, so then we get this way, people, that y equals x plus b by 2a perfect squared. We will take minus sign out from both. This sign will be there for minus, because once you take minus sign out, that minus and this plus, when you multiply, we get minus. So then there we get b squared minus 4ac divided by 4a squared, like this. Right? People, now we introduce another new symbol for this b squared minus 4ac. That is the Greek letter delta. That is the Greek letter delta. Okay, I introduced that there, right? Let delta equals b squared minus 4ac, people. For this b squared minus 4ac, we put delta. And this b squared minus 4ac is called as, people, discriminant of the quadratic function. Discriminant. Understand? Right. So this is called as the discriminant. This is called as a discriminant. Right? Discriminant. So now, people, using this delta discriminant, I can rewrite this. Meantime, I can remove the bracket by multiplying this, people, what? A. Right? Okay. Then we can write like this. Y equals, by this a we multiply this. What do we get? A times x plus b by 2a perfect squared minus, this a comes before this term, and now this term is nothing but delta, divided by 4a squared. People, a certain cancellation you can do here. A squared means what? A into a. 1a you can cancel down with this a. Another 1a should remain at the denominator. To do that one, to show that one, people, if we use another step to show this a squared dash a into a, useless, no, that is useless step. So then, people, finally, after cancellation, as I explained, definitely only 1a letter should remain at the denominator, no? Then, people, right? So there we can, all right, people, cancel down this a with 1a here. I cancel down this a with this 2. It doesn't say this a and 2 cancel down, people. Finally, after every simplification, right here, we should have at the denominator 4a. Until we get 4a at the denominator, we cancel down the rest. Real happening is this, people. A times delta divided by 4 times, here we have a squared, no? A squared mean a into a. Then this a and this a, when you cancel down, finally we get delta upon 4a, no, people? Here, delta upon 4a, no? The same thing only, people. If I do the simplification like this, we have delta upon 4a. That way we use, people, in order to what? Save one step. Otherwise, to write this one, 4a squared as 4 into a, we must write another one step, no? Right? So therefore, people, remember, there are such simplification we have to be familiar. Right? So now we get like this, right? And then we get, people, like this. A times x plus b upon 2a perfect squared minus delta upon 4a. Delta upon 4a. Now, people, by observing this right hand side, you can very easily determine x coordinate at the vertex. X coordinate at the vertex. We know, people, that is obtained by changing the sign of these two opposite. So then the x coordinate of the vertex is going to be minus b upon 2a. What is the y coordinate of the vertex, people? Soon after this whole thing with the sign, what do you have? That is the y coordinate of the vertex. That is the y coordinate of the vertex. Right, people? Now we can write, therefore, coordinates at the vertex, and, people, Certainly we can go to find what the roots. Okay, all right. Now start people up here. Come up with this. Right now, yeah. Write down people up to this. Right now, people, right? Okay. Now you can very easily determine the vertex. There are 4 vertices. Vertex is a point now. It has x coordinate as well as y coordinate. X coordinate is obtained how people change the sign this to opposite. Then we get minus b upon 2a, right? Minus b upon 2a. Right? Y coordinate is obtained soon after this bracket with the sign, everything you have to take, minus delta upon 4a. This is the vertex. This is the vertex. Right. People, you know the next one. What is that? The roots. People can remember we found the roots of quadratic function last week in several times, people. They are after completing the square of the quadratic function. Can you remember the way we found the roots? What we did, people? We put 0 for what? Y. We put 0 for y. Then we found what the corresponding x values. Understood? We'll do that one now. Right. Then you can write 4 roots. Set y0. Why is this, people? When you put y0 here, 0 equals what, people? The right hand side. That says the right hand side equals 0, no? 0 equals this means this equals 0, the same thing. Right now? Yeah. So then we can write, we get, that implies, people, you know this double line arrow says what? When you put y0, the one we get. That's what this double line arrow means. Double line arrow has the meaning gives, reads, implies, means. They are the usual meaning of double line arrow, people. Okay, right. So then we get there this way: a times x plus b upon 2a of x squared minus delta upon 4a equals 0. This is what we get. Okay. Now I bring this to right hand side. A times this. Once I take this right hand side, this minus sign will be plus delta upon 4a. People with me do. With me do. Right. The next step is, people, this a you can bring via the right hand side denominator. Right. So then we get x plus b upon 2a of x squared is equal to delta divided by, once you bring this a via here, people, that a and this a make a squared, then we get 4a squared. Okay, people, right. Now, I can take the square root on the right hand side, then we can eliminate this square. Then what do you get? X plus b upon 2a equals plus or minus square root of this whole thing on the right hand side. Okay, and then I write that we are here x plus b upon 2a in the left hand side. Since this square will be eliminated, I can write it without bracket like this. Equals now plus or minus the square root of the right hand side whole fraction delta upon 4a squared. Now in this case, people, we have to find the square root of this fraction. That means you have to take the square root of the numerator as well as the square root of the denominator. Then what I do next step, while we are bringing this to right hand side, I take the square root of this numerator and denominator both. And then let's see what we get. I write that we are here. Okay, then what you get is x equals minus b divided by 2a. It's now plus or minus. Once you take the square root of this fraction, square root of the numerator, then root delta. Square root of this 4a squared, square root of 4 is people 2, square root of a squared is a. So then we get root delta divided by square root of 4 is 2, that of a squared is a. Now here you can see 2a here we have, 2a here we have. People, now x equals, we get minus b plus or minus square root delta divided by 2a. This way we can write. People, can you remember this kind of expression in your O levels? If not, see whether you can remember. Our delta was people b squared minus 4ac, no? Shall I write for the place of delta that x equals minus b plus or minus square root of b squared minus 4ac. I wrote for this delta divided by 2. People, I am sure that this time you should be able to remind this thing. I think you can remember this. This is the people you learned in your O levels to find the roots of quadratic equation. This formula, of course, people, directly you were given without proof, that you use to find what? Roots or the solutions of quadratic equation when you don't have factors of the quadratic equation given. This formula without proof, people, we used. The same thing, people, we obtained by proving that today. So then, people, how to take the two roots? First, we take plus sign and simplify. We get 1x value, that is 1 root. Secondly, we take this minus sign and we simplify. We get the second value 4x, that is second root. So therefore, this is the people formula which gives the two roots of a quadratic function. Understand? Now, one message, of course, I noticed why we put delta. People, that is the usual practice of discussing this lesson. Delta is called as discriminant. We put this delta for our people convenience of thinking and writing in the lesson in the future. Delta b squared minus 4ac called as a discriminant. That's much easier to use rather than writing always b squared minus 4ac. That's the purpose. So therefore, people, this is the formula which gives the two roots of the quadratic function y equals ax squared plus bx plus c. Okay, so this gives now the two roots. This gives now what, people? The vertex. Now, people, using this vertex, this results and what, people? This you can now determine coordinates at the vertex and the roots. Then we can, if necessary, draw the graph with the help of this formula. Okay, right, come up to this, people. Right, first come up with this. Right. Now, I'll write this result here. Vertex coordinates, it's minus b by 2a and minus delta by 4a. And the roots given, x equals minus b plus or minus square root of b squared minus 4ac divided by 2a. Okay, now we will right. In the quadratic equation tutorial, people, I think in 2-3 questions there in the tutorial to prove this one. I put that same question at 2-3 places, people. This proof was in a past paper question. After another 2 weeks, people, we count past paper sums, right? Then you can notice the importance of getting this way, this one. You can work out that past paper sum, very recent past paper question we have. Okay, right. And people now, let's see how to use this knowledge to draw a given quadratic function. So then you know, people, so far we have 3 ways. No, firstly we discussed how to drawing the graph by using the table. Secondly, people, we determine using the factors, and factors means roots, and thereby vertex, and drawing that. Third method is, people, what? The completing the square method. We determine the vertex and the roots and we drew the graph. Now fourth method is, people, directly using that. Okay, let's see how to draw one graph and then we jump toward the other part of the today lesson. Okay, yeah, right. So then write down, people, this question like this. Write down as a question here. Write down, find the roots. Find the roots and the vertex. Find the roots and the vertex of y equals x squared minus 5x plus 6 and sketch the graph. Right, sketch the graph, people. That is the question. Very simple one. We'll start this, people. Okay, this is a question. Right, people. Now, what I am going to do first is this. The given quadratic function, I am going to write like this: y equals x squared minus 5x plus, people, 6. Now, I am going to compare this given quadratic function with the quadratic function y equals ax squared plus bx plus c. Understand? That is called as the standard way of writing the quadratic function. What? Y equals ax squared plus bx plus c. That form is called as what, people? The standard form of writing the quadratic function. Okay, so I'm writing just below this, that one, in order to determine this a, b, c, right? Because here, this x squared coefficient is 1. Then the place of a here, what do you have? 1. Place of b, what do you have, people? Not just 5. With the sign you have to read, minus 5. Place of c, what do you have? 6. So therefore, you can first determine what this a, 1, b, minus 5, and c, 6. Why? We need those values, people, to substitute at these places to find what? The coordinate at the vertex and the roots. That's why we determine like that ABC values. Okay, now people, we can now write minus b upon 2a. Why? Minus b upon 2a is the x coordinate at the vertex. Okay, then what is our minus sign? What is b here? This b is here, minus 5, put minus 5 divided by 2 times a is 1. People, what do you get there? Minus minus plus 5 by 2. What is this 5 by 2? The x coordinate of the vertex, right now? Yeah. Secondly, people, this minus delta upon 4a, right? People, what is minus delta upon 4a? Minus delta means what, people? B squared minus 4ac, right? Delta is that, remember, divided by 4a. Now we substitute for these figures and simplify. Then we get the y coordinate of the vertex, right? Minus b squared. B is minus 5 now, people. All right, minus 5 squared minus 4 times a is 1, c is 6. Right here, people, instead of the multiplication, we put this way dot. That doesn't imply the decimal, right? In other words, we use in place of that cross, the multiplication sign, dot to represent the product multiplication, right? And 4 times a means a is 1, no, 4 into 1. We get what, people? Minus 5 perfect square means minus 5 into minus 5, that is plus 25, right? Plus 25 here, here 24, here people what? 4. So then we get minus 1 upon 4. This is the y coordinate of the vertex, people, right now? Yeah. Then we know the vertex, right? Now we know the vertex. Now we know the vertex. Yeah, for vertex, we can write here. Vertex is, people, 5 by 2 minus 1 by 4. Vertex is okay. And people, the other thing is, we know the vertex. Now we need the roots. Why? We said in drawing, sketching a graph, first we have to identify whether the graph is minimum or maximum. Last week I told you, people, it surely this is a minimum graph because x squared coefficient is positive. That is we know. Just now we found the coordinates at the vertex. Another one more we need. What is that, people? The roots. Then of course we can sketch the graph. To find the roots, people, we can use this now. Right? Substitute in that time, people. Find 2 answers for x. And now we can very easily, right, sketch the graph. Right? Okay. Now we'll come to that roots. X equals minus b plus or minus square root of b squared minus 4ac divided by 2a. Right. Minus b. All right. B is minus 5, people. B is minus 5. Plus or minus square root of b squared minus 5 squared minus 4 times a is 1, c is 6. Divided by 2 times 1. Now we'll simplify this. X equals minus minus, we get plus 5 plus or minus. People, what do you get there? Right. Minus 5 perfect square is minus 5 into minus 5 plus 25. 4 into 1 into 6 is 24. Divide by 2. Okay. 25 minus 24 is 1. Root 1. It's 1. Right now? Yeah. Then I write that we are here. X equals 5 plus or minus 25 minus 24 is 1. Then we root 1 divided by 2. You know, people, square root of 1 is 1. 5 plus or minus 1 divided by 2. People will take this plus sign. Once you take this plus sign, we get x equals 5 plus 1 by 2. That is nothing but 3, no? 5 plus 1 is 6. 6 divided by 2 is 3. Take minus sign. X equals 5 minus 1 divided by 2. It is nothing but 2. 5 minus 1 is 4. 4 by 2 is people 2. Now, okay. Now we can sketch the graph. 2 roots we know. Vertex we know. Graph is minimum we know. We can sketch the graph. People, this time the workings, of course, more workings available when you use this method. We never use this method here in after. I actually illustrated this method we can use to get these answers. Understand, people? You should know this method too, right? As a A-level math student, because after getting a pass for maths, once you eligible to enter the university, people, around your home, people, some your brothers and sisters might come to you, get some knowledge of mathematics, maybe OL, grade 9, sometimes maybe AL. That occasion, of course, people, you have a goodwill, no, right? So there's a warm welcome by the society. Why? The future engineer, people. Then this kind of simple thing, if you don't know, people, what will happen to you? Nothing will happen. But people, that is not ugly, no. Right? As a math student, people, you should know this. Understand? Right? Okay. Right. So, and this will be very helpful in the lesson. You will realize that when you do some questions in the future. Right? So therefore, people, we have to learn all possible things. We have enough time. We don't have such hurry to cover up the syllabus. We have enough time, right? We can do a lot. We can go more deeply. Every capability we have. So therefore, people, no need to be hurried. We'll discuss this lesson completely. And people, the next lesson in the free seminar, next month, won't be able to do because I have to do all past paper sums at least from 2020 to 2010. 11 past papers I must do. It takes more time. Then I hope at the first week of the August month, again, I continue the free seminar, starting the new lesson vectors. Starting the new lesson vectors, and Monday class, most probably we can finish in Monday class, people, we start the velocity time graph. Then people, I think the first term, all the lessons will have been covered by then end of the August. In your school, first term, all the lessons will have been covered by the end of, right? The end of August. Then we keep term test. Yeah, enough class. In our class. Fortunately, by that time, if this postal department work properly, I'll send you the paper to your home and we take 3-hour time period. All right. All right, people, you have to write, I am watching here and thereafter. If it is a particular way of getting your answers to me, then I correct them. If not, I discuss the thing here and I give the marks. Okay, so then people, we can go to the second term. Then anyway, people, your school will be starting, not now, not in this year, most probably next year beginning. That occasion, people, we will have finished the second term lessons also. Right, people? Right? So then we have one is free seminar, the one is our class. Okay. So then soon after starting the physical classes, I don't think that we can have this free seminar in every week. But the proper online class we keep, that occasion people, that occasion, we can actually do everything very easily because we have done lots of things before starting your school. That's my future plan. Right, people? Okay. Now we'll come to the sketch of the graph. Right. Right. So then I am going to draw the graph. Right. In the class people, though the number of students today is 46, 45 now, including me. Now, actually, soon after the class, I get messages, I need the recording, I didn't have the current, and I didn't have the signal, and so on. I think nearly more than 100 requests coming asking to put the recording. Right, people? So now that is another bad habit. People are very lazy to join the class. They always find the comfortability, because if I provide them the recording, no need to sit on the chair 3 hours, no. Watching the recording half an hour, getting a break, and another half an hour, right? I can remember last logarithm lesson or whatever, the polynomial function lesson. In my class, nearly just more than 100 students available those times. Now there were more than 700 views for that lesson. So either some of the students in the country watched that, or else the same student 2-3 times before finishing the lesson watch the recording also, people. So anyway, people, that's anything good, but I recommend if you join the class, that is much better than watching the recording. Okay, so now you are very live with me now. Understand, people, right? So now before you come to the class, now teacher in front of you, that feeling you have. But people, now when you watch that recording, you are very lethargy, very lazy. So rather than that, people, attending to the live class is much better than watching the recording. Okay, all right. So those guys, people, some people, they said, we have another class, they won't give the recording us, you only give the recording us. That's a good help to us. All right, so keep it up like this, otherwise we will be helpless. Yeah, people, we can do that. But people, I am saying the best thing is that. Okay, now we'll come to this. Right, so then this is y-axis, this is x-axis, right? Okay, the two roots are, people, 2 and 3. I mark here 1, here 2, here 3, here 2. I take bigger scale here, 1 here, 2 here, 3 here. Right. Okay. The vertex 5 by 2. 5 by 2. This is 2, people. This is 3. 5 by 2 means 2.5. Exactly midpoint. Y coordinate is -1 by 4. Somewhere here. Right. This is -1 by 4. Here and here is the graph. This is the graph, and this way we can sketch the graph. This way we can sketch the graph. Right. So this is the y-axis. People, this point you can find, the point where the graph cuts the y-axis. You know, at this point, on the y-axis, when we consider any point, people, on the y-axis, when we consider any point, its x-coordinate is 0, right? When you put 0 here, 0 squared is 0, -5 into 0, that is 0. Then both this will be 0 and giving 6 to the right, but left-hand side y equals 6 means the coordinate here, y coordinate is 6, right? So then just write that as 6. This is the point. So this is -1 by 4. -1 by 4, y coordinate, no? X coordinate is 5 by 2. Okay, this is how we use that data to get this graph, right? Right. Now people, we are now moving to another very important one. Another very important one, right? How to find the point cut in y-axis, asking a question. Put y0, x0 people here and here. Put x0. Why? When the graph cuts the y-axis, this is the point, no? In this point, x coordinate is 0. Why? On the y-axis, when we consider any point, people, on the y-axis, when we consider any point, in that point, the x coordinate is 0. Therefore, put 0 here and here. 0 squared is 0. Minus 5 into 0, 0. 0 minus 0 is, this is 0. 6 is here. 0 plus 6 is 6. Y is 6, this point. Okay, no? Right. Right, people, now we come to the next important one, right? Next important one. People, now, shall I erase this all? Right. Right, now I'll take this very important part of the lesson, right? The quadratic function was this, right? Okay, its roots are given by x equals minus b plus or minus square root of b squared minus 4ac divided by 2a. Up to here, no doubt. Right. Okay, people, now using this same formula, only in the previous question, the two roots we found. People, can you see here the two roots we got? One is 3, other one is 2. You can see this 3 and 2 both are real values. Real values means real numbers. That's the obvious thing, no, people? All right. And the other thing is these two values are different. Then what kind of roots available in this case, people, for the quadratic function? Real and distinct. Distinct means different. Real and distinct. That's well obvious, no? People, now this way, this real distinct roots coming because of this reason. Inside this root sign here, what is this? Inside this, what do you have, people? Delta, no? Delta, no? We use the notation for this b squared minus 4ac, delta, no? Here we have delta. In this particular question, the previous one I'm talking, this previous one, people, this delta is 1. It is at the moment positive. At the moment positive, right? Then we could find square root of plus 1. When we have positive value, for any positive value, people, we can find square root. Okay, so we could find square root of this plus 1 as 1. Then after plus and minus, we have 1. Taking plus sign and minus sign separately, we got two different answers for x. There, of course, we found two real roots which are different, distinct real roots. People, can you get one hint as a condition? Then what is the condition required to have real distinct roots? Can you guess that, people? This delta figure should be positive. Delta should be positive. How to write positive? People, any real number which is positive lies on the number line here. This is the place of 0 on the number line. On the right of this 0, people, all the values are positive. And not only that, people, all the numbers on the right of 0, all the numbers on the right of 0, people, greater than this 0. Then if we have somewhere here x, since this x is on the right of 0, x is definitely positive. Not only that, people, this x greater than this 0. When we go to right along the number line, people, all the numbers are increasing. So therefore, people, if we need to write a particular real number is positive, what's the best method? Best method is, people, taking that real number as x. Since it is positive, if it is positive, that should lie on the right hand side of 0. If any number on the right hand side of 0 greater than 0, then x greater than 0 is the way to say that x is positive. So therefore, in order to say this delta discriminant positive, people, how to write that? Delta greater than 0. Therefore, you can very clearly understand the condition required to have real distinct roots is, people, delta greater than 0 or delta positive. People, next one, the same example I'm going to use to explain this very easily. You can understand it, right? Okay, so then once I take that again, suppose, people, in the previous question here, when we were finding this one, here we got 0. Here we got 0, suppose. Then delta is 0. What is the square root of 0? Square root of 0 is, people, what? 0, right? Then this is 0. Therefore, here I have to write 0. Okay. Here 0, no? Then this is 0. This is 0. 5 plus 0 is 5. 5 divided by 2. 2.5. 5 minus 0, 5. 5 divided by 2, 2.5. Now what can you say, people? One root is 2.5, other also 2.5. What can you say? The roots are still real. Why 2.5 are real number? 2.5 is a real number, still real, but they are equal now. They are equal now. People, this is what? Coincident roots. Coincident means what? Coincident means what, people? Overlap, coincide, overlap. Two roots become equal, that means overlap. Then you can very clearly understand what is the condition required to have coincident roots. Delta must be, people, what? Delta must be 0. The condition required to have coincident real roots is, people, the delta discriminant 0. People, now you can very clearly understand. One student asked one question: why do we put delta for this b squared minus 4ac? People, now, right, when you explain this condition, delta equals 0 is the condition required for coincident roots, much easier to express our idea, people. Otherwise, b squared minus 4ac equals 0 also correct, people. Inconvenience, no? So therefore, as our convenience only, we use for this delta for the discriminant. Okay, then what is the second condition? For the coincident roots, the discriminant delta must be 0, right? For the real distinct roots, delta should be positive. Right, now we'll come next one, people, here. Suppose here, for this delta, we get minus 1. Delta, now minus 1. People, inside the root sign, now we have what? Minus 1. Can somebody tell me what is the square root of minus 1? What is the square root of minus 1? People, nobody can give an answer for this using real numbers. Using real numbers, nobody can give. Using real numbers, nobody can give, people. Using real numbers, yeah, nobody can give. Right? Some answers suggesting the answers are correct, people. Right, people? So then this is called as imaginary. If this is not having a real number, people, this can't be found in real numbers, then you can't find this number in real number. then this answer x cannot be found in real numbers. Such numbers are called as imaginary numbers and complex numbers. People remember, we have in pure math syllabus very interesting lesson called as complex numbers, right? In that complex number lesson, we discuss in more detail how to give an answer for this, but not in real numbers, in complex numbers, in imaginary numbers. People, at the moment we know what? At the moment we know what? We know about the real numbers. Whenever we try to find people, right? Okay, when we need to find something, we always measure that by using people real numbers. But people, there are some other kind of numbers called as what? Imaginary numbers and complex numbers. Imaginary numbers and complex numbers. We don't know anything about them so far, people. One day, if you will learn about the imaginary numbers and the complex numbers, people, now you are more open than this. Then you can give answers for them, this kind of numbers also in the future we do, right? Soon after, people learning these complex numbers, of course, you can give an answer for this. Remember, people, when we do electrical engineering or electronics engineering, the complex numbers are very important. Most of the theories are coming with the complex numbers, not the real numbers, people. So therefore, that lesson is very important lesson. Very huge lesson we have. Very interesting one, right? I'm of course very interested in teaching that lesson because very good logic available there. That is maths, people, right? So therefore, we'll learn that in detail. At the moment, remember, if you find something like this, people, nobody can give an answer using a real number for this. So therefore, this is imaginary. Therefore, roots cannot be found, people. Roots cannot be found in what numbers? In real numbers. Roots cannot be found in real numbers. So therefore, no real roots for the quadratic equation. Quadratic function. Equation also same. So then what is the condition then? For imaginary roots or no real roots, delta, this one should be negative. People, how to write negative number? A number which is on the left of 0. All the numbers on the left of 0 are negative. And the other thing is, if we have a number which is on the left of this 0, all the numbers which are on the left of this 0 less than this 0. All the numbers which are on the left of 0 less than the value of 0. And also they are negative. So therefore, if we need to write a particular number, say y is negative, the best way of writing that y as negative, people, y less than 0. Y less than 0 means what, people? Y is a negative real number. Like that, people, if we need to write delta is negative, how to write? Delta less than 0. Now you know the mathematical conditions required for a quadratic function to have real distinct roots, real coincident roots, and imaginary roots. People, real distinct roots condition, delta, the discriminant positive. Real coincident roots, delta equals 0. Imaginary roots, or sometimes we call as complex roots, delta negative. They are the mathematical condition required to have the 3 types of roots. Last week we explained what are 3 possible types of roots existing for quadratic function. For each of them, people, now we have a condition. Then, people, before drawing the quadratic graph, we can determine whether the graph has real distinct roots, real coincident roots, or imaginary roots by checking the sign of delta. Understand? So therefore, the key tool is therefore, people, delta. So that is why it got the name discriminant. That explains the nature of the roots. Discriminant means that, people, right? Discriminant, the meaning of that is that. It explains the nature of the roots. That is why it got this name, discriminant. Understood? Now, people, our next heading is that. Write down the heading. Write down the heading, people. The condition required. A heading is a bit long, people. Right? The condition required. The condition required the condition required for the roots of the quadratic function y equals ax squared plus bx plus c. To have real distinct roots, comma, real coincident roots, and imaginary roots. Imaginary roots. That is the heading, people. Go to the last line, underline that one. Okay, right. Now we'll start. Write down like this: y equals ax squared plus bx plus c. Write down. Y equals, write down this. Y equals ax squared plus bx plus c. Before write down, people, here let. Write down before this, let y equals ax squared plus bx plus c. Now write down. The roots of this function are given by I will write down this: x equals minus b plus so minus square root b squared minus 4ac whole thing divided by 2a. Okay, people, I am going to write in this b squared minus 4ac as delta, right? Write down. That is, okay, x equals minus b plus or minus root delta divided by 2a. Right. This way now you can write. Now in terms of delta, we explain the possibilities. Okay, right. Write down like this. Number one. Write down: if delta greater than 0. People, you know what is meant by greater than 0? Delta is positive. Greater than 0 is positive. Right. Write down. If delta greater than 0, then write down. If delta greater than 0, underline. Under that, write down like this. Then root delta. can be found in real values, then simple x will have two different values, TWO, two different values. Two different values. Therefore, there exist two distinct real roots. TWO2 distinct real roots. Right now? Yeah, that is number one. Second one, people put number two. If delta equals 0, right? Write the next line. If delta equals 0, root delta, then you can write, then root delta equals 0. Therefore, people, you can write x equals minus b plus or minus. People, now this root delta only here, now 0 we get here, 0 divided by 2a. People, once you add 0 to this minus b, once you subtract this 0 from minus b, people, this numerator won't change. Though we take plus sign and minus sign separately, people, both occasions, the same answer we get for x. There are two values for x, but they are now equal. That is the case of coincident roots. So therefore, we get the same value for x, right? Then we get plus sign here, people. What do you get? Minus b plus 0 by 2a. Minus sign gives us, people, x equals minus b minus 0 by 2a. Both the values now here minus b by 2a, because when we add 0 to something, it never change. Subtract 0 from something, never change. Right, people? Then we get the two answers being equal like this. You can see equal. The two values we get for x are now equal, people. That is the case. Real coincident roots, right? Real coincident roots. Write down. Therefore, roots are real and coincident. Real and coincident. Real and coincident. Real and coincident. Right now? A third one, people, will write third one. Number 3. If delta less than 0. Less than 0 means what, people? Negative. Huh? Any number less than 0 is negative, people. Remember that. We can very easily observe that by drawing the number line. On the middle of the number line, we have 0. To the right, positive values. To the left, negative values. Okay? Yeah. So now you can write. If delta negative, if delta less than 0, then root delta is imaginary. Root delta is imaginary. Root delta is imaginary. People, within bracket write down. Within bracket write down. within bracket write down. Root delta cannot be found in real numbers. Root delta cannot be found in real numbers. Write down. Therefore, no real roots, 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 or roots are imaginary, or roots are imaginary. Okay, now people, we can write the summary putting a star mark there. Put a summary, people. Put a star mark and then write. Right, like this. Write down. Therefore, write down. Therefore, the condition, therefore, the condition required, condition required for the roots, of y equals ax squared plus bx plus c to be right. Write down number 1. To be real and distinct, to be real and distinct is delta greater than 0. Number 2, real and coincident is delta equals 0. Number 3, imaginary is delta less than 0. Delta less than 0. Delta less than 0. Delta less than 0. People, then by observing this, can you tell me at what occasions the roots of this function become real? There are 2 occasions. When delta positive, real roots come in. Delta 0, real roots come in. In this case, the roots distinct, different. In this case, roots are equal. But both occasions, that 2, the roots are coming in real numbers. So therefore, you can see the quadratic function, this has real roots at 2 occasions. What are the occasions? When delta positive or delta equals 0, what? That quadratic function has what? Real roots. We'll write that as our last step right now. Therefore, when delta greater than or equals 0, this is how we write both at once. Therefore, when delta greater than 0 or equal to 0, we write these 2 together like this: delta greater than or equal to 0. When delta greater than or equal to 0, the roots of the roots of y equals ax squared plus bx plus c are real. Right? Are real. People, now we can match this situation with the graph. Last week we do know the different types of graphs showing real distinct roots, real coincident roots, imaginary roots. Now we can give for each of the graph the mathematical condition for them to be like that. Right, people? Yeah, if I roughly draw another small diagram, people, sets of diagrams here, right? People, the diagrams you identified for real distinct roots, yeah, the graph cuts the x-axis at two different points like this. That is how we identify graphically real distinct roots. People, now two real distinct roots. The case required for this is delta greater than 0. This is delta greater than 0, number one. Second type, people, we notice this way. Graph touches the x-axis like this. This case, the coincident real roots case. This occurs, people, when delta equals 0. Third case, this way, people. Graph lies completely above the x-axis or completely below the x-axis. So that graph does not cut the x-axis. That is how we identify imaginary roots. Imaginary roots, people. For that, now mathematical condition we have. What is that? Delta negative. We get like this. These are the people final summary. Right? Draw these graphs also. Small graphs. Draw this people. Right, people? Okay, no? Yeah. Now we finish the quadratic functions. People, our heading, our lesson, quadratic equations is our lesson. People, saying the lesson as quadratic equations, so far we learned about quadratic functions, right? Well, now only we go to what? Quadratic equation lesson. Right? So far we learned which are very important to understand quadratic equation lesson. Now write another subheading as quadratic equation. Quadratic equation. Write down subheading as quadratic equation. Right, let's see how to define this quadratic equation. Right, people? You know, we identified this as, people, quadratic function. No? So far we discussed about the quadratic function, some properties, how to draw the graph, roots, nature of the roots, condition required for the roots to be this, and this, so on, people, we discussed. Let's say, people, what is then quadratic equation? Right. You know, people, in this quadratic function, we define this A, B, C belongs to set of real numbers. This is notation. With A not equal to 0. A can't be 0. We said if A is 0, x squared term will disappear. Then no longer we define that as quadratic function. All right. So therefore, definitely there should be x squared term. In order to keep x squared term in the right hand side, its coefficient should not be equal to 0. Okay. Now, people, when I equate this y to 0, what do you get? 0 equals this. That means this equals 0. Ax squared plus bx plus c equal 0 coming. This is the one people we define as quadratic equation. This is the way of defining the quadratic equation. In the quadratic function, right? Y, this y be equal to 0. Then what do you get as the result? Ax squared plus bx plus c is equal to 0. That is defined as quadratic equation. People, can you remember in sketching the quadratic graphs, one occasion we equated this y to 0. For what purpose, people? To find the roots. Those roots are given by now what? This what? Quadratic equation. So therefore, people, if the quadratic equation defined like this, when you find the answers for x of this quadratic equation, those answers are nothing but the roots we found for what? Quadratic function. So therefore, solutions of quadratic equation mean what, people? Solutions means answers for x. By simplifying this, we get those solutions are nothing but the roots of the quadratic function. Then this quadratic equation can give two roots, two answers for x. What are the possible ways of existing that answers? That two roots are what, people? Real and distinct. Two roots are real and equal. The roots are imaginary. Now, people, very easily we can analyze the quadratic equation and its roots. Then quadratic equation is defined, people, like this: ax squared plus bx plus c equals 0, where this a is not equal to 0. That a is this say, no, people. We said there a is not equal to 0. So therefore, the solutions of this quadratic equation are the answers of x. Once you simplify or solve, we get those answers for x can have in basically three types: real distinct roots, real coincident roots, and imaginary roots. For each one, now you know the condition required. For real distinct, people, what? Delta positive. Real coincident, delta 0. Imaginary, delta negative. See, and the other thing is the roots of this quadratic equation are given by now, people, the formula in the morning we obtain like this. See, now very easily you can discuss, people, about this quadratic equation. Most of the classes, right, they start the quadratic equation, people, the lesson from here itself without explaining the previous part properly. Most of the classes, right? Up to now, the most of the classes they did like this, but because I give this recordings freely, then hereinafter, this way, the notes might be coming, the classes might be coming, people, in the future. Okay, right? Our people, most of the people are imitating now, people. So then, of course, hereinafter, this kind of notes are coming. Usually, this happens in every year. People in, I can remember in one area in the country, some masters, I think this incident occurred 2-3 years back. Some masters collected my tutorials and changing the name at the foot of my tutorial and put in their own name. They do classes. That's okay, fine. Why? People, this is a particular service to the students, no? Right? And now, soon after I started the classes at Kurunagala, then once I do like this a new lesson, right? I take little time now, people, to explain everything, and we go slowly, at the very beginning. That should be so, people. Then you can very clearly understand. If you learn everything and going along the track, people, much convenient, no? So I do usually slowly. Those masters, of course, most of the masters, they are not fully engaged in tuition. They are school masters, as well as they do tuitions. You know the way they do. They, of course, always try to fill the record book, no? Then they do very quickly everything. Then anyhow, people, they have finished a particular lesson before I start that in the class. Then people, usually I change my tutes once a 2 years. New questions are put. Then at the beginning of the class, in the physical class paper, I delivered the tutorial. Then 1 or 2 students or 3 students came from that area. So the same tutorial we got, no sir. We got the same tutorial, sir, but this name was not there, something else. Then people, that occasion, the students, that 3 particular students thought, I am copying his tutorial and I am changing his name and putting my name in that. See the things happens, right? See things happens. Now, like that, people's situations occurring, right? After getting that one, after getting that, they are changing their names and everything. Now I am the one copied from them. Similar things happen, people, in the society. What to do, people? What to do, right? Now, in my case, with me, people, I have more than 200 model papers. Most of the model papers, people, I put questions by sitting myself. I take the questions, I think a question, I design the question, I put that into the tutorials. Some occasions, people, the same question in the past set by me, some occasions I can't work out that question. Why? Up to that level, deeply I concern and form the question. But at the time I am going to work it out, people, that concentration lost. I won't get what that method of working out the question. Sometimes I will be helpless. Sometimes the student mind says, you can't work out that question. True, people, because the question set by me, I can't do that. So like that, people, I dedicate for the levels like these people, but the other guys simply take them. But people, the most important thing is this. There can be some printing mistakes, no, people, in this tutorial also, plus minus printing mistakes can occur. But those masters, people, now they are on tute, no, then they should be able to work out any question in that, no, because they only put that them, no. Because of one printing mistake, people, and they were unable to work out that question. So I asked purposely that student just ask from your master, not in order to put him in an inconvenient situation. I needed people to verify that this is not, I copied this one from their masters. I know in that particular question, there is a printing mistake. Before I work it out, I asked them to get this from their masters. They said that question is wrong, don't work it out. Then I told you, this minus, this plus sign should be minus, then work out this question answer is coming. See, people, that's the thing, right? So that kind of things usually happens, right? Almost all schools in Kandy area, not almost all means in the English medium available. Most of the people, they use questions from my tutorials, and some other areas also using like this. That's good, people, because this is for the students, right? And the same way doing them, they make particular image that I am copying their materials. That is the bad thing. That is the bad thing. Anyway, people, we patiently take them and we'll do our own way. People, we do something to the nature, no? Then nature will, right, serve us and protect us, right? Okay, then we go to the next part. Right, next part. Right. Write down the heading as quadratic equation. Right. Now we'll write one sentence. Consider, write down, consider the quadratic function y equals ax squared plus bx plus c with a comma b comma c belongs to set of real numbers and a not equal to 0 and a not equal to 0. Write down. Now, when y equals 0, now when y equals 0, this function becomes, put here 0 people, what do you get? Ax squared plus bx plus c equals 0. Ax squared plus bx plus c equals 0. Write down here where a not equal 0. Now write down. This equation is called as, this equation is called as the quadratic equation. Quadratic equation. Right. Start from new line, people. Write down the solutions. People, what is meant by the solutions? Answers of x. The solutions, answers of x of this quadratic equation are called as its roots are called as its roots. And these roots are given by people, what is the formula? These roots are given by that formula today we obtained. X equals minus b plus or minus square root of b squared minus 4ac whole thing divided by 2a. Right? How easy to learn now, people? Yeah, you know everything, a big picture now you have in front of you. Right? What if I started from ax squared plus bx plus c equals 0 is called as the, right, people, quadratic equation, and said this way, nobody will understand this, people. Okay, all right. So therefore, quadratic equation means only one case of the quadratic graph, quadratic function, or quadratic graph, right? These roots are given by x equals minus b plus or minus square root of b squared minus 4ac divided by 2a. People, not only this, as we discussed the nature of the roots for the quadratic function, the roots of the quadratic function are the roots of this quadratic equation. Same thing. So therefore, earlier the discussion we of course made regarding the nature of the roots. We discussed three types of roots: real distinct, real coincident, imaginary. That three types again true for what the same quadratic equation roots. Why? Same thing. Okay, people. Then write down. First write down this and then write down one sentence. Write down the different types of roots. 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 The quadratic equation. The quadratic equation ax squared plus bx plus c equals 0 can have the comma r can have comma r as follows. As follows. Write down, people. First one. Number one. Real distinct roots. What is the condition required? Delta greater than 0. Discriminant positive. Condition required is number 2. Real coincident roots. Condition required is delta equals 0. Next one, people, imaginary roots. Imaginary roots. Condition required is the delta less than 0. Delta less than 0. Right, people? Then here also the quadratic equation has real roots at 2 occasions. At 2 occasions, the quadratic equation has real roots. Here, real word involving here and here. This is the case, only case, imaginary. Then real roots having at 2 occasions. The condition required is delta greater than 0 or delta equal to 0. That's the last sentence. Now, write down like this. Therefore, the quadratic equation ax squared plus bx plus c equals 0 has real roots, when delta greater than or equal to 0. When delta greater than or equal to 0. Right now, people? Right. Okay. Now, after this, we come to some questions. Right? Yeah. Before that, people will take a small break of 10 minutes. Okay. But you must join the class again, right? There are at the moment 40 students. At the beginning, there were 47, right? Don't be lazy, people. At least 3 hours you will be able to stay in the class, because the annual examination, 3 hours and 10 minutes you have to stay. Now extra 10 minutes getting to read the question papers, right? So 3 hours means for adult students really nothing. But we take a small break in the middle. I know, not like in physical classes, by watching this screen, bit difficult to manage, right? Another thing is, once you go out from your room, sometimes your parents might say, huh? Right? Parents might say, why do you come out, and so on. Now people will take a small break of 10 minutes, then we'll come back to the lesson, right? And we discuss some few questions today, and we come to next day, the class. Next day, people, we go to more important theories. After another 2 classes, people, we come to the past paper sums. Okay, right. Okay, we'll come to break. Now 11, come at 11:10. Right, we'll start. Now people, we come to one question. This question is in your tutorial, question number 13, right? But I'll write that question in the 13 on this board, right? Right. This is the question, people. Question number 13 in the tut. Show that the roots of x squared minus 2ax plus a squared minus b squared minus c squared equals 0 are real. Where a comma b comma c are real numbers. Right. This is the question, people. Show that the roots of x squared minus 2ax plus a squared minus b squared minus c squared equals 0 are real. That's what we have to prove. People, what is this really? It is a quadratic equation. Quadratic equation contains x squared term, x term, and terms independent of x equals 0. Such equation only, people, we identify as the quadratic equation. The standard form of writing quadratic equation is, people, what? Ax squared plus bx plus c equals 0 is the standard form, right? The same form here we have. Here x squared term available, x term available. This all 3 terms like this single term c. So then this given equation, now we can compare with the standard quadratic equation. Standard quadratic equation is, people, this ax squared plus bx plus c. Now by comparing this given quadratic equation with this standard one, you can get the values of this a, b, and c. How? Compare, people. X squared coefficient here is 1. Then the place of a, what we have is 1. X coefficient is b. B here, this minus sign 2a is the b. See, people, this whole thing is c. Then first thing is, people, by comparing with the standard quadratic equation, you have to determine that a, b, c values. Why? People, we need to find the delta, the discriminant. By its sign only, we can see about the nature of the roots. So therefore, we are going to write next occasion the delta, discriminant. Okay, people? For the discriminant, we know discriminant is defined to be how, people? Delta b squared minus 4ac. No. What is this b? B is the x coefficient. What is this? A and this c. A is the x squared coefficient, c is the constant. So therefore, with the standard quadratic equation, comparing with the standard quadratic equation, the given one, we have now determined that simple A, B, C values to write the next step, the delta discriminant. Understood? Right. So therefore, by comparing like this, people, I can write for the place of A, what do we have? Right, people? For the place of A, we have 1 here. For the place of B, what do we have, people? B minus 2A. For the place of this C, what do you have, people? C is A squared minus B squared minus C squared. Okay. First of all, by comparing this given equation with the standard quadratic equation, determine that A, B, C values which we need to write the discriminant delta. Okay, right. Now you know, people, in a quadratic equation, the two roots can exist in 3 ways, no? Real distinct, real coincident, and imaginary. We need to prove this quadratic equation has real roots. People, quadratic equation will have real roots at 2 occasions. What are the 2 occasions? First occasion is if delta positive, real roots. Second occasion is, people, delta equals 0, also real roots. Then in order to show that this equation has real roots, people, we have to prove the discriminant of this quadratic equation. We can find delta or the discriminant for this quadratic equation. The discriminant of this quadratic equation, people, we have to prove is either positive or 0. Then only we can say this quadratic equation has real roots. Okay. Now our purpose is what, people? Our aim is what? We find the discriminant of this quadratic equation with the help of this A value, B value, and C value, and putting them where here. Then we get the discriminant of this specific quadratic equation. And we have to prove that delta discriminant, we get particular expression now. We have to prove that expression is either positive or 0. It never be negative. If we can prove like that, people, discriminant is either positive or 0 means the roots are real of the corresponding quadratic equation. That's how we prove in this case. I think you got this idea. Now, people, after comparing like this, we determine like this. Then I am going to write delta of this quadratic equation, delta. Delta is what, people? B squared minus 4AC. Right. We can write delta B squared. B is minus 2A. Minus 2A perfect square minus 4 times. A value here 1. C value here this. A squared minus B squared minus C squared. This is what we get. Right. This is what we get. Now we'll simplify this furthermore, people. Right. Here, delta. People, minus 2A squared. How to square this? We have to square the minus sign. Minus sign squaring means minus sign and minus sign. We have to multiply. Squaring means we have to write 2 times, no anything. X squared means what, people? X squared means x into x. Like that, minus squared means minus sign into minus sign. Minus minus, when you multiply, it's plus, people. Right. 2 squared, 4. A squared minus, here we have 4 A squared minus B squared minus C squared. Take this 4 out, people. 4 is common. Also take 4 out. Here we have a squared. Here also take this 4 out. We have within bracket this way. Now by minus sign, we can multiply all these 3 terms. We get delta equals 4 times a squared. This minus, here we have plus. Minus and plus make people minus. Right? A squared. Minus and this minus make plus b squared. Minus and this minus make plus c squared. Cancel down these 2. Okay. Now delta equals, we get these people within bracket. Right. We came up to this. Right. Now people tell me, we need to prove what? The discriminant delta is either positive or 0. That's what we have to prove. Now, can you give me an idea? To prove this delta is always positive value or 0. In other words, it can't be negative. People think like this. We are given in the question that simple A, simple B, simple C are real numbers. What do you mean by real numbers, people? Yeah, real numbers means in our day-to-day life, people, the numbers we use with plus, minus, fractions, decimals, positive integers, negative integers, and those are called as real numbers. People take any real number. I'll take our B as C minus 2, C as people 3. Then B squared means what, people? Minus 2 squared, no. That is 4, no. Then C squared means what, people? 3 squared. That is 9, no. Then this B squared plus C squared means what, people? 4 plus 9, no. B squared plus C squared is 4 plus 9, no, people. That is nothing but 13, no. This is positive value, no. Like that, give any 2 real numbers for this B and C, and after squaring them, add them up. What happens? People, this we get positive value. The reason is what, people? The reason is what? After squaring any real number, the real number can be positive value or that can be negative value, people. After squaring that, the resulting number is positive. So therefore, whatever this B takes, positive or negative real number, after squaring that, for this B squared, what do you get? Positive. Similarly, for the C squared, what do you get? Positive. 2 positive answers when we add, people, the answer is positive. Therefore, definitely the within bracket is positive. Multiplying that by 4, people, positive value multiplied by 4 means answer is another positive value. Therefore, we can say delta is positive. But there is another case, people. What if this both B and C become 0? B 0 and C 0. B 0 and C 0, people. Then what is B squared? B squared means 0 squared. 0 squared means 0 multiplied by 0. 0. C squared. 0 squared. That also 0. When this both B and C take 0, that occasion B squared 0, C squared 0, 0 plus 0 is 0, 4 into 0 is 0, delta becomes 0. Earlier we said delta positive. Now we say delta can be 0. Surely, people, this delta should be positive value or 0. It never take what, people? Negative. Then according to this, we can say sum of 2 squares, remember, people. Sum of 2 squares of 2 real numbers. Sum of the squares of 2 real numbers, people, always positive or equal to 0. Equal to 0 case occurs when each real number takes 0. Therefore, people, obviously, we can say the right hand side is either positive or 0. It never be negative, because of here we have b squared plus c squared. Sum of the squares of two real numbers is always positive or 0. So therefore, people, this right hand side is either positive or 0. Therefore, delta is positive or 0. Therefore, roots are real. Understand? That is how we prove. Okay, then we can write the answer like this. Write down, since a squared plus b squared greater than or equal to 0. Delta greater than or equal to 0. We can write, since this one, we can write 4 times. Here, multiplication 4 available, no? 4 times a squared plus b squared greater than or equal to 0. But 4 times, not a squared, no, b squared plus c squared. Since people here, b squared plus c squared, I even drawn that. Since b squared plus c squared greater than or equal to 0, 4 times b squared plus c squared. 4 times b squared plus c squared. Here we have b squared plus c squared, no? Right. Since b squared plus c squared greater than or equal to 0, multiply that by 4, that also greater than or equal to 0. Then people, we can say, therefore, delta greater than or equal to 0. Because why? This is the delta now here. If this is positive or 0, this is equal to this, therefore delta greater than or equal to 0. Then what can you say, people? Then what can you say? Yeah, the roots are real. Hence, the roots of the quadratic equation are real. That's how we prove that. Right. Okay, people, now next one. Another question we'll discuss. This is question number 14 in the tute. Right. We'll write that too. Question number 14 in the tute. Right. Write down, show that when a smaller than c smaller than b, the roots of a minus b perfect squared x squared plus 2 times a plus b minus 2c times x plus 1 equals 0. Are imaginary. Show that when a smaller than c smaller than b, the roots of this equation a minus b perfect squared times x squared plus 2 times a plus b minus 2c times x plus 1 equals 0 quadratic equation has, people, imaginary roots, right? Imaginary roots. People, when we try to explain about the nature of the roots of a quadratic equation, definitely the key thing we have to use there is what? The discriminant of the relevant quadratic equation. Understand? By its sign only, people, we say the nature of the roots. So therefore, by this we get the idea that we have to find the sign of the discriminant of this quadratic equation. Okay, therefore let's try to find the discriminant of this quadratic equation. You know the first step, people, this given quadratic equation we match with the standard quadratic equation and we determine that simple A, simple B and simple C involving with the discriminant delta given by b squared minus 4ac. So therefore first step is that. Okay, all right. Right, now I'm going to write. By writing here the standard quadratic equation like this, I'm going to compare how, people, the place of a here we have a minus b here this whole thing, c here this one, then a is this a minus b squared. People, this a means in the standard quadratic equation x squared coefficient. That one in this case is a minus b squared, right? And what is this b, people? With this 2 a plus b minus 2c and c, people, 1, right? Now I'll give 2 minutes, people. Give me the simplified form of the discriminant delta. Delta is written how, people? B squared minus 4ac. The b, a, c figures we now identified by comparing with the standard quadratic equation. Substituting them where at these places, give me this simplified answer of discriminant delta. Thereafter, we'll see how to take this answer. Right, I'll give 2 minutes. Right, delta b squared. B is this, people. It's perfect squared, no? Right. 2 times a plus b minus 2c whole thing squared. We have write it like this. Right. This is okay. Minus 4 times a. A is this. A minus b perfect squared. And c is here 1. Right, no? Right. Right, people. Now the square here. 2 squared 4. And we have to square this also. Delta 2 squared 4. And this one a plus b minus 2c perfect squared. Right? Minus 4 into 1 is 4 times a minus b perfect squared. Right. Now, people, this 4 is common for these 2 terms. Take that 4 out. Right. So then what do you get here? A plus b minus 2c perfect squared minus a minus b perfect squared. Like this we have. People, now don't go to square this. We can very easily simplify it like this. Consider this as here, this is a perfect square. Here we have a perfect square. In the middle, we have minus sign. Then here we have what? Difference of two squares. Difference of two squares. You know, people, the factors of difference of two squares. If we have x squared minus y squared, what are the factors, people? X squared minus y squared factors are x minus y times x plus y. X minus y times x plus y, people. Right? Then think this says sure x. If this within bracket part only, I am saying to take as x, this is x squared. Then take this as y. Within bracket, this a minus part only, I am asking you to take as y. X squared minus y squared. Then you can write the factors of this. Right. Then write the factors. Delta 4 times. What do you get, people? A plus b minus 2c minus x minus y. No, y is this. Put bracket and write a minus b. First factor we wrote. Second factor, people. A plus b minus 2c plus a minus b. This way you can write the two factors. Right now, people. Two factors we can write like that. X minus y, x plus y. Now you can very clearly see here. When you remove the bracket by multiplying this minus sign, this a, what do you get? Minus plus minus plus minus. Minus a come in. Here we have plus a. Then people, a and this minus a you can cancel down. That's okay. And now here look at this. This minus sign and this minus sign we multiply. Minus minus we get plus. Plus b. That plus b and this plus b, people, together 2b. Here b, from here also we get b. B plus b is 2b. And here minus 2c. First bracket is this. And come to these people here. Here plus b and this minus b you can cancel down very easily. A and this a, 2a minus 2c. We get like this. We get like this, people. Right. Now you can see here, in this bracket, 2 is common. Take that 2 out. Then once you take this 2 out, people, we have within bracket b minus c. In this bracket also, people, take this 2 out. Then that 2 is before the bracket, a minus c within bracket. The 2 taken out from this bracket here, the 2 taken out from this bracket here, then we have 4 into 2 into 2. 4 into 2 into 2 means, people, 16. 16. Now, since we have taken these 2 out, people, b minus c, we get within the first bracket. Second bracket, we get, people, a minus c. This is what we get for our simplified discriminant. Okay. All right. Now we need to prove, people, the given quadratic equation has imaginary roots. You know, quadratic equation will get imaginary roots, people, when delta is negative. That means we have to prove the sign of this right hand side is negative. How to prove that, people? Yeah, to prove that right hand side is negative, now you can use this result given in the question. A smaller than c, smaller than b. People, I'm going to mark this ABC on the number line. Look at this. This is the number line. The smallest one is, people, A. Secondly, see, the biggest is B, people. Right? Now see here. People, what can you say about B minus C? This one. Here. B bigger, C smaller. Think here. This is like 12. This is like 9. This is like 5. Then B minus C means 12 minus 9. 3, no people. Positive, no people. Therefore, this is positive. See, A minus C. A minus C. 5 minus 9. Difference is, people, minus, no? Yeah, this is minus. The size is not important. We need only the sign. This is positive number. This is negative number. Positive number multiplied by negative number. Plus minus, when you multiply, people, answer is what, people? Minus, no? Then this together minus. That is multiplied by this 16. 16 is plus. Plus sign, these two together give us minus. Plus and minus, when you multiply, people, we get minus. So therefore, this gives us delta less than 0. Delta negative. Negative means less than 0. Delta negative mean, people, you know, roots are imaginary. Right? Roots are imaginary. Right. Therefore, roots are imaginary. To determine this product as negative, people, we of course used the given thing this that we have to mention here. I put this 5, 9, 12 for our convenience of thinking about the sign of the difference. Right? Don't allocate like that, people. I just took them in order to get a clear picture about the differences. Right? This is how we show. Delta negative, therefore, roots are imaginary. Right, people. Right, we'll take another one more question. Then we can come to the end of today's seminar. The next question is, people, question number 15 in the tutorial. Question number 15 in the tutorial. Right, we'll write that. I'm going to erase this all, right? I think you finished this. Asking any past paper question we can do? No, don't try again. Don't try past paper questions yet, people. Right now, don't try. So we have to do more. After next week, little of the past papers possible to do. After 2 weeks, people, 2 classes you can do. Don't be hurried to do past papers. First take the knowledge. Thereafter we'll do. Okay? Don't try the past papers yet. Right, people. Next one. Question of 15 in the tutorial. The last question today we're supposed to discuss. Right. Write down like this, people. Write down. If the equation x squared minus 2 times 1 plus 3k x squared minus 2 times 1 plus 3k x plus 7 times 3 plus 2k equals 0. Has equal roots Find the values of k. Find the values of k. That is the question. Find the values of k. Right. People, now in the question we are given this quadratic equation has real equal roots. Has equal roots. We are given this is a quadratic equation. This quadratic equation has equal roots. They are equal roots means people real coincident roots. That's the meaning. Real coincident roots is the meaning. You know the condition required to have real coincident roots. What's the condition, people? The discriminant of the quadratic equation should be equal to 0. Then we have to start the question from there because we are given this particular quadratic equation has equal roots. Equal roots, to have equal roots, the condition is people discriminant delta should be equal to 0. There we have to write again the discriminant for this quadratic equation. Therefore, we have to compare this with the standard quadratic equation ax squared plus bx plus c and determine a, b, c values to write what? The discriminant delta, right? Okay. Then we'll compare this, people. Ax squared plus bx plus c equals 0. Here we have 1, no? Right. B means with the minus sign this whole thing. C is, people, this whole thing. Then you can determine this. A equals 1. B minus 2 times 1 plus 3k. And people C 7 times 3 plus 2k, like this. Okay, now we can write one sentence there. Write down. After determining like this, A, B, C values, people write down like this. Since the given equation has, since the given equation has equal roots, delta equals 0. Delta equals 0. What is, people, delta? B squared minus 4ac equals 0. B squared, square of this, minus 2, 1 plus 3k, perfect squared, minus 4 times A, 1, C, 7 times 3 plus 2k equals 0. Right. People, now square this and simplify the left hand side. Then we get to the left hand side. Again, a quadratic equation in simple k, people. Give me that. I'll give 2 minutes to simplify this. Hurry up. Simplify this. Give me to the left hand side quadratic. Let's see, people. Here, what do you get? We have to square this minus 2 square. People, what is minus 2 squared? Minus 2 into minus 2 plus 4, right? And square of this 1 plus 3k. Here, 4 into 7 into 3 plus 2k equals 0. Equals 0. Now here, you can divide both sides by people 4. Right hand side we have 0. No? The both sides of an equation we can divide by any value. Both sides you have to divide by the same value. We can divide by the same value. The equation won't change. When you divide this by 4 people, what happens? We divide this by 4, 4 and 4 will cancel off. We divide by this by 4, 4 and 4 will cancel off. We divide 0 by 4. When you divide 0 by 4, what's the answer, people? 0. So then what do you get? We divide this by 4, then what do you get? 1 plus 3k perfect squared minus 7 times 3 plus 2k equals 0. And people, now we have to expand this. What is this? This is like A, this is like B. Here we have A plus B squared. You know the expansion of A plus B to the power 2. What is the expansion? A squared plus 2AB plus B squared. Like that, you can expand this. 1 squared, it's 1 plus. What is the middle term? Multiply these 2. And that answer again we multiply by 2. 2AB, no? Right. When you multiply this 1 and this 3k, 1 into 3k. When you multiply something by 1, the same answer come in, no? Same thing come in, no, people? 1 into 3k is 3k. That 3k we have to multiply by 2. 3 into 2 is 6k. And this 3k we have to square. How to square 3k? We have to square 3 as well as k. 3 squared is 9, k squared. Right. Then remove bracket here. Minus and plus make minus 21. Minus plus minus. Here we get 14k equals 0. Right, people. Now I write this 9k squared first. 9k squared. 6k and minus 14k. What are the answer, people? Minus 8k. And people, here we have 1, here minus 21. 1 minus 21, people, minus 20. See here, you get what, people? Quadratic equation in k now. How to find the solution of this quadratic equation? We can use today that formula we learned, x equals minus b plus or minus, that you can use. But easily we can take that roots. How, people? By factorizing this, considering this as quadratic equation, you know that method. In that method, people, how to factorize this? Yeah. How to factorize this, people? Yeah, you can factorize this way. What? This k squared coefficient 9, this constant minus 20, we have to first multiply. 9 into minus 20. This is minus 180. This minus 180 we must write as a product of two numbers so that their algebraic sum to be, people, minus 8. That two numbers are nothing but minus 18 into plus 10. See here, when we multiply these two, we get this. When we add this and this, we get minus 8. This is coming. Then I can write, people, 9k squared minus this 8k. We can write 18k plus 10k minus 20 equals 0. Now, by these two, people, what is common? 9 common, because this 18 you can write as 9 into 2, no? Here we have 9, here we have 9, and k also common. Then take 9k out. Then what do you get? This k squared we can write as k into k, no? When you take 9k out, another k is within bracket. This 18 I can write 9 into 2. Then that 9 and this k when you take, we get minus 2. Right. From these two terms, people, we can take plus 10 out. Plus 10 is common. Then here we get k minus this 20 we can write as, people, 10 into 2. Once you take 10 out, 2 remain within bracket like this. Now, this k minus 2 here, k minus 2 here. You can take that k minus 2 out as common factor. Once you take this k minus 2 out, people, from here, when you take this out, we get 9k. When you take this out, we get plus 10 equals 0. Right. Now, people, this product equals 0 means this is 0 or this is 0. Right. K minus 2 equals 0. Or, people, 9k plus 10 equals 0. Bring this to this side, we get k is 2. Or take this to this side, minus 10 and divide by 9. Taking this here. Then the two values of k, 2 and minus 10 by 9. This is how, people, we take that k values. Right. Okay. Right, people, now, this is the end of the today lesson. Right? This is the end of the today lesson.